All right. So before we get diving into things, at the end of class today, I'll talk about and we'll kind of see deployed something we haven't done yet, which is the first hackback assignment. So notice the due dates ways out February 7th, so not next Friday, but I believe that's the following Friday. All right. So it'll be kind of related to what we're talking about today and this week. You might be able to incorporate some of what we talk about early next week, but I wanted to get it up there early. We'll talk about it at the end of class, a little bit more about how it works. You'll see that pop up. What else will pop up after class today? Module 2 quiz and Module 3 reading, right? So every single week, the reading will be one module ahead of what we covered. Quiz will be whatever we covered that week. Right? So you'll see those pop up. I think originally I'd said it's 11:30 after that second section that I have. I think I've got the module readings now. It's not important that those are late. So those should pop up like 5-10 minutes after class. I think I have it set to be 9:45. So those will be released. And then the quiz will be released at 11:15 once both of my sections are done. So you'll have until the end of the day, Monday, to complete both of those. Okay. So kind of getting used to this routine with the class, because I've tried to keep the format similar so due dates aren't all over the place with those readings and those quizzes. Other than that, so you'll see those pop up here after class today. The quiz is there ready to go, that pack-back assignment, and then that module 3 reading. You should now be able to see not only that reading, I've got the slides up for next week. We might have a little bit of time, depending on how quick we go today. I might start module 3 just to get some kind of easy stuff out of the way, just give us a little more time next week for some more difficult things. If we don't get there, I didn't really plan on doing it, but we might have a little extra time today. So I wanted to make sure those slides were available if we do get there in class today. Okay. Other than that, any questions for me before we jump into material here today? Okay. Good. All right. Staying warmer a little bit today than the last couple of days. All right. So we left off last class talking about production possibilities curves. We're really kind of looking at this at like the individual level. So we had these nice like linear production possibilities curves. We were drawing it out for each country. So let's now think about if we had like a global production possibilities curve, or the way I think I'm going to kind of phrase it today. Make sure I actually do some of this stuff ahead of time so I don't think through things wrong. Instead of 2 countries in the entire world, let's think about like we had 2 individuals and we're thinking about like just one country, right? So we're looking at one economy's production possibilities curve. So let's say, I had this example. So let's say we've got there we go. Person 1 and person 2, right? So I was thinking about this for whatever reason. Here we had, this will make a little bit sense here in just a second. I don't know. I was thinking about this the other day, and kind of your faculty, whether or not you realize your professors, some of them are more specialized at teaching, some of them are more specialized at research. So I'm thinking about like, if I'm a university and I'm trying to make this decision, right? I want to make sure I have some faculty who are really good at research, some who are really good at teaching, and I want to make sure the ones that are good at teaching are doing more teaching than they are research, and vice versa, right? So here, let's think about if I had some numbers, just nice, easy ones, and maybe this is like a semester here. Now, obviously, like they might teach more students, but I'm trying to keep the numbers kind of easy here for us. Okay. So this is just like what we talked about last class. We have 2 goods. This is how much each person can produce if they're using all of their resources to produce this one good. So if it helps, if you want to make this more general, this is like any example, this would be good X. And here, this would be whatever the other good Y would be, right? So in order to understand who we're going to rely on to start producing either one of these goods, we want to know who is better at it, right? Who can do it at a lower cost? We should be relying on whoever in our economy can do something at a lower cost. So what represented costs? When we had these production possibilities curves, what did we say represented the cost of the x-axis good? The slope. So what we're thinking about is something like this, right? So I've got like my students down here. I've got quantity of papers on my y-axis. And I would say if person 1 was only writing papers, they could produce 5. Teaching students, they could teach 30. I missed a little bit, but there we go. The other one we had at what? 2 and 40. So I try to draw this to scale, right? Because if I compute what these costs are, how do I find the slope? Slope would be equal to what? Change in y over change in x. So here this would be -5 over 30, right? Or 1/6. And this would be what? Change would be -2 over 40 or 1/20. Right? So if I'm thinking about the cost of one paper to each of these individuals, what tells me, and actually here, sorry, I'll start with this. The cost of teaching one more student, right? If I'm wanting the cost of the x-axis good, what should tell me that? We just said the slope. So I've got the cost here for person 1 was 1/6. Here it was 1/20. Okay. So this is where I think last class we started out and finding the slope in general was like an integer value. It doesn't have to be the case, right? It could be some decimal value. So if I then want, okay, what's the cost of my y-axis good, right? How do I find that? The inverse, or 1 over the slope. So 1 over 1/6 is 6, and 1 over 1/20 would be 20. So I've now got my costs of both individuals in my economy. We'll assume starting out, and all the models I'll give you make it simple, and the same would apply if I have more people, but let's assume we only have 2 people in our economy, right? I've got a university, I only have 2 faculty members, right? Well, the next thing we want to try to understand is, what is this production possibilities curve look like for the entire economy? So not just each individual, but for the entire university, right? Which includes these 2 individuals. Or think about it this way, if we had 2 people and there was only 2 people like in our entire country, right? That's the kind of thought experiment we're doing. So if that's the case, what would our economy-wide production possibilities curve look like? So we'll keep here well, actually, I'll show you that you can do it either way. Let's do the quantity of papers now on my x-axis and the quantity of students on y. So I flipped the goods. I want to show you that it doesn't really matter, right? You can actually build this production possibilities curve either way. I think this way is going to make the math just a little bit easier, but it's kind of also a nice way to show you, like, it doesn't matter. As long as I have the costs, I can build the production possibilities curve out no matter what good I want to put on my x-axis. So if I've got this economy, if I only have the 2 people in my economy writing papers, how many total can I get? Well, person 1, if they use all their resources, all their time, they can produce 5 academic papers. What about person 2? So total, yeah, right? If I'm using all of my resources, all of my individuals' resources to just produce these academic papers, I can get 7 at this university or in my economy. What if I want to just teach students, right? How many students can they teach? Yeah, 30 plus 40 or 70. Now, what we won't do is, unlike the individual production possibilities curve, our economy-wide production possibilities curve will not just be a linear line in between those 2 points. And we'll think about why. So initially, who do I want to rely on to start writing academic papers? And as a result, there's a trade-off, right? If we want more of the x-axis good, these numbers represent when we're using all of our resources. So when I'm using all of my resources to just teach students, I was at a total of 70. If I want to start to have my faculty or the people in my economy write papers, there's a trade-off. They're not going to be able to teach as many students. So who do I want to rely on to start writing papers first? Whoever can do it at the lowest cost, or whoever has a comparative advantage. So if I'm looking at the costs now to my x-axis good, who had the lower cost here? So this was the cost of 1 additional paper was 6 what? Students, right? It's always in terms of the other good. So who has the lower cost? Person 1. So I'm going to rely on them first. So initially, if this was person, sorry, I didn't have this labeled as well. Here we go. I wrote it in order, but person one and person two. So person one, I'll initially start relying on them. So as they start to write papers, at a certain point, they've stopped teaching entirely, right? At a certain point, person one is only writing papers and has given up teaching 30 students, right? So the slope of my production possibilities curve here would be whatever the cost was to that first individual who could do it at the lowest cost, which was what? -6. Or we said when we talk about cost generally, we drop the negative sign. But to be complete, the slope is actually -6, right? Our production possibilities curves are always downward sloping. Now, at this point, if I'm using all of person one's resources to now just write papers and not teach students, how many papers will I have in my economy? Well, they can write 5. How many students will I be teaching? Well, to write those 5 papers, how many students is this person no longer teaching? What was the trade-off? 30, right? Or each one cost them 5 students. 5 times 6, I had to give up teaching 30 students, or I had to give up 30 of that other good. So instead of 70, I would be at what value here? 40. Right? So it's kind of always easy to identify these 3 points on your economy-wide production possibilities curve, which is if I'm using all of my resources, everybody in my economy to just produce that y-axis good, that's that y-intercept. If I'm using everybody in my economy's resources to just produce the x-axis good, that would be my x-intercept. And here, I'm going to only give you these kind of more simple models of 2 people. So that point in between is going to be where the person who has a comparative advantage in the x-axis good is only producing that good, right? The person who had the comparative advantage or the lower cost in writing papers now is only writing papers, which inherently, if person one had a comparative advantage in the x-axis good, who is going to have a comparative advantage in the y-axis good? We said last class, it has to be the other person, right? And it's a result of, I think I went through the math, like if you take an inverse, now the denominator has to be larger, so it'll always be the case. Sure enough, who has the lower cost here? Might be hard if you don't compute this, but this is going to be, right, 1/6 is a little bit higher than 1/20, right? This is what? 0.05, and this is it 0.1667 or something, 66 repeated, right? So a little bit lower. Person two has the comparative advantage in that other good. So this middle point will represent when each person in my economy is only producing what they have a comparative advantage in. So person one is only producing what they had the lower cost in, papers. Person two is only producing what they had the comparative advantage in or the lower cost, which was teaching students. Or can you think about these producing an X or a Y is good? I'm just kind of using a slightly different example to show you. We can think about this under the context. Okay. Now, from here, if I want to get any more than 5 papers, who am I going to have to start relying on? Well, person one has used all of their resources. So who am I going to have to rely on? The other person in my economy, who is going to have to be producing this at a higher cost. So notice with my economy-wide production possibilities curve, and the same would apply if I had more than 2 individuals, we can just highlight it with 2. What's happening to the slope of my economy-wide production possibilities curve? It's getting, tried to draw it to scale. What's happening to the slope there? It's getting, no, it's 8 a.m., but steeper, right? It's getting more vertical, right? Or it's representing that as I want to produce more of this x-axis good, I have to start relying on people who can't produce it as efficiently or can't produce it at as low of a cost. I have to start relying on people who can produce it at higher and higher costs. So my economy-wide production possibilities curve will always have this kind of like increasing slope, or what does the slope represent? Increasing cost to my x-axis good production. Okay. Now the same would apply if we had more than 2 individuals. You can kind of think about it this way, like, I don't know, if I want to start relying on people to like fix cars, right? Who am I going to choose first? Mechanics, right? People who are really good at using all their resources to fix cars. It's a low cost to them not doing other things. Eventually, they've used all their time. I start to have to rely on people like me. My cost would be very high because it's going to take me all day to read up on whatever I'm trying to do, probably still not do it right. And I'm giving up working on other things that I'm much, much better at, right? I'm going to have a really high cost. So our economy, as we want to produce more and more of something, we have to start relying on people who can do it at a higher and higher cost, right? Or said differently, initially we'll rely on people who can produce it at the really low cost, right? So not just a too good model, or sorry, too good, a two-person model. But if I had any two goods, so let's think about, this is more of like what we talked about last class. So let's say I want to think about, I have like this trade-off between producing agricultural products and technology products. So we can always do this, like in terms of two goods. I think like last class I was saying like airplane parts and wheat or something like that. We can also think about this more of like batches of goods, right? So these are like technology products and these are agriculture. It can include multiple products, but they're like different types, right? And different people are going to be more productive or have different costs for producing these technology products than others. So what's going to happen with my economy wide is initially, who am I going to rely on to produce these first few technology goods? Whoever can do it at the, so what's going to be true about the slope of my production possibilities curve? It's going to be pretty low cost. So if this value is like negative 0.0001, what's true about my slope? Is it flat or steep? Flat, right? What is the slope of a flat line? 0. So we can't ever have exactly, right? There's always a trade-off. So it's going to be something above 0, but it might be really, really flat. Now, after that person has used all their resources to produce these technology goods, who am I going to have to rely on next? Whoever can produce it at the second lowest cost. And then if I want to keep going after they've used all their resources, third lowest, fourth lowest, fifth lowest, sixth lowest. So if I'm drawing this like as a nice continuous line, our economy-wide production possibilities curve, when we look at everybody in the economy, it's going to have this kind of like nice bowed outward shape. Why? Because what that's representing is that initially, to produce this x-axis good, my costs are low. I'm relying on whoever can produce this good at the lowest cost. As I want more and more of that, I'm going to have to start recruiting people who are giving up doing other things that they're really good at, or other people who have higher costs to producing that x-axis good. So as we kind of produce more of that x-axis good, the slope of our production possibilities curve, we know is going to be increasing in absolute value, right? It's a larger negative value because it represents that my cost of producing that good are increasing. I'm relying on less and less efficient or people who aren't as good at producing, who don't have a comparative advantage in producing that good. Okay. Questions on anything here? You know, I'm kind of throwing a lot, trying to kind of put the pieces together here to get to this economy-wide production cost. So we started out a two-person model. I might ask you something like that on the quiz, right? To identify these points. I think there's a problem in the practice problems that's like that as well. So I'll show you another question I could ask you, and it gets a little bit harder, a little trickier to think about. So first of all, I probably do this I'm overkill, but any questions before I go on to the next thing? Yeah. In this case, I won't ask you to calculate the slope, right? Because it's what's going to be true about the slope at every single quantity. It's going to be different, right? So I only ever ask you about like slopes here if we were looking at like a two-person model. In fact, let's say, right, instead of being at one of these 3 points, I said it's kind of easy to identify the 3 points on this economy-wide production possibilities curve. We only have 2 people. But what about the points in between? So let's say I want it to be here. I don't know. I'm a university, and I've decided I want 6 academic papers to come out of my university. Right? I want 6 of this x-axis good. Well, I know that if I want to move from that 5th to the 6th quantity here, who am I going to have to start relying on? The second person, right? The person who could do it at the higher cost. How much is each paper costing my university there? If they take their time to write another paper, they can't use that time to teach 20 students. So how many fewer students would I be teaching here? Moving from 5 to 6? 20 fewer, right? So where would I be at on my production possibilities curve? 20 students being taught, 6 papers being written. Think about it a slightly different way. What if instead I only wanted 2 papers? Well, is this showing up as green or does it kind of look black? Hold on. That probably doesn't help, but well, I was going to color code this, but here, hopefully you can kind of tell the difference here. So if I only want 2 papers, who am I going to be relying on to write those first 2 papers? Whoever can produce it at the lowest cost, going from 0 to 2. I haven't relied on it, so I can rely on whoever has the comparative advantage. Now, how much is each paper costing me? 6 students, so how many students am I going to have to give up? So going from 70, right, I'd be at what? 58? So sorry, if this is a little small, hopefully you have a little bit more room. The y-axis value here was 58. Right? So I can really find any point along this production possibilities curve once I know the costs of the individuals in my economy. Now, I'll never push you more than a 2-person model if I asked you to do that. But in theory, I could do that with an economy-wide. As long as I knew the costs of everybody in my economy, I could do the same thing. The math would become a little bit more, all right, it's going to be a little more cumbersome. Okay. Any questions over anything there? Okay. So where are we at in time here? Doing pretty good. Go back to the slides here. So I think I've actually already said all of this. I think I had a different example than the one I used. But if I was thinking about like, I don't know, the choice between me and probably anybody else to either write economic papers or write songs, right? I'm always going to have the higher cost. So to kind of line up with what we were talking about, the example, let's say, just to kind of keep this consistent, we were talking about the trade-off between teaching students and writing those papers. So we said, as we produce more of that x-axis good, the cost is going up, right? The slope is increasing. So this is kind of a weird way of saying this, but what's happening to the cost of my y-axis good, the last unit I produced, as I produce more of the x, so as I produce more of the x-axis good, inherently, what has to be happening to how much of the y-axis good I'm producing? I have to be producing, someone pointed down, less. So if the slope tells me the cost of my x-axis good, as that slope gets a larger and larger value, how do I find the cost of my y-axis good? It would be 1 over that. So if I take 1 and I divide it by a larger value, what's happening to the cost of my y-axis good? It's going down. So as the cost of your x-axis good is going up, inherently, the cost of the last y-axis good or unit that you produce is going down. Okay. Any questions? Once again, this kind of summarizes like what we were talking about kind of visually. The other thing that we'll kind of point out here is I was always showing you points on the production possibilities curve, right? All of those points are going to be what we call production efficient. I think I left off here. I probably should be, just to be a little bit more technically correct. Sometimes I get lazy with my language. We would call this production efficient. I was using all of my resources to produce, some combination of these 2 goods. So any point that was below my production possibilities curve, we're going to say that's being inefficient. Because any point below that, that means that there are some resources that just aren't being used. Now, the easiest way to think about this, if I have an economy-wide production possibilities curve, and I don't know, let's say I'm producing 500, whatever the agricultural product is. If I'm at a point that's below that, what has to be true? Well, how would I find this point? Let's say I had more than 2 people. How would I find this point? Let's say I had 10 people in my economy. How am I coming up with that value? I would just take how much each person can produce and add them up, right? I'm only producing that one good. So if I'm producing anything less than whatever that value is, what has to be true? I'm not using everybody. Because if I was using everybody to produce this good, I'd be all the way up at 500, right? And the fact that I haven't taken any of their resources to produce the other, I'm being inefficient. I must just be wasted. I'm not using some of the people in my economy. Right? So that's going to be true about any point that's below my production possibilities curve. That represents I'm not using all of my resources. The way that we were finding all of these points, we were inherently assuming, well, this is if I'm using all of the resources of the individuals in my economy. The next kind of thing we'll talk about is, what if I wanted to produce, so let's say, I don't know, this was 300. I'm only producing technology products. Why can't I produce 600? Well, what does this represent? I'm relying on every person in the economy to produce this good. So if everyone's producing this good and I'm getting 300, I don't have enough resources to get past that point. I can't get to 600. So any point past my production possibilities curve, all these points are going to be what we call unattainable, right? So any point underneath, we said we're being inefficient. We're not using all of our resources. Any point past our production possibilities curve, we don't have enough resources to get there. We'd like to be out there. Like, we'd like to have more of both of these goods, but we don't have enough people in our economy. Okay. Any questions on this? We kind of have like these zones, right? So I think might have a nice visual here in the slides in just a second. Oh, nope. I had it, so I was going to draw it out for you. So I'll make this a little bit more kind of nice here. Let me see. You guys, okay, you can see the dot cam. What do I want here? Okay. Just want you to have, you could probably get the information from here, but we've got time, so I want to be a little bit more. So anything out here, we would say this is unattainable. Anything under our curve, this would be combinations of the two goods that are inefficient. And once again, we could write this out just to be like a general form. So good X and good Y, whatever the two good example I give you is. And then what did we say? Every point on the curve was what? Efficient, or we'll be careful because this in a second, we'll talk about a different type of efficiency, but we would say that it's production efficient. We're using all of our resources. Okay. So those are kind of our zones. Right? Any questions on this before we keep moving here? So I've got something here just to kind of make sure we're clear on this. You might see something like this on the quiz or the in-class quiz I use later. So what points here would be production efficient? B and C. What points would be inefficient? Just D, right, under the curve. What point is unattainable? The only one left, right, A, okay? Now, the next thing we're going to talk about is we've got these production efficient points, but what point do we choose in our economy? So once again, I'm going to build this out. I'll probably kind of be saying some of the things that are in the slides later on. So, but I think listening and seeing me work this out will be more helpful. And then you have the slides to always go back and reference. So let's say I am keeping this like in general form, just good X and good Y. Whatever this good, it's the technology products, agricultural, PCs, wheat, academic, whatever the two goods I'm thinking about my economy producing. We talked a little bit, I mentioned this last class, and I think I used the idea of a car to really amplify this example. But as I buy more of something, what's happening to the marginal benefit? What did we say this word marginal means? Additional, or the change in the benefit that I'm getting. So we said, if I go from 0 to 1 car, what's the marginal benefit? Huge. I can get around. I don't have to rely on the bus system. I can take my friends' places. Everyone wants to, whatever. If I go from 1 to 2, I can only drive 1 car at a time, right? So this is the idea that if I'm going out to eat, if I go and get Chick-fil-A and I get a spicy chicken sandwich, the first one brings me a huge marginal benefit. The second one, still pretty high, but I was already kind of full. The third one I'm probably at negative at that point because I'm going to be too full. I can't do anything the rest of the day. I'm going to start feeling bad. So this idea is that we have more of something. What do we say is happening to the marginal benefit? It's going to be decreasing, right? So as I produce more of something in my economy, the same intuition applies. If I have one interstate in a specific area, that's a huge marginal benefit. What if I put a second interstate that literally runs right next to it? And I guess it makes traffic a little bit, less, but it's not near as valuable as that first one, right? So anything that we produce in our economy, it also falls victim to this idea that as we have more of it, we're having this declining marginal benefit, okay? So we said these points are production efficient. So why don't I choose, what point do I choose? Do I produce this combination of X and Y, this combination, what point do I choose? Well, every single amount of good X is going to have a marginal benefit associated with it. What is the slope of my production possibility, my economy-wide production possibilities curve? What does that tell me? It tells me what for the X-axis good? The cost. And in fact, it not just tells me, we say it's not the total cost, it was how much one more unit would cost me. So that would be the marginal costs, all right? So what is happening as I produce more and more of this X-axis good, we said our costs are increasing. So as we consume more of something in our economy or produce more of something, we have decreasing marginal benefits and increasing marginal costs. Right? So where is what we would call the allocative efficient point? Which of these points on the curve would make our society like the happiest, if you want to think about that way? Where would the net benefits be maximized? So remember we said we can think about net benefits. You may not see this terminology used as much in the text. This is something I kind of like to do. I think it helps make a little more sense. What did we say the net benefits to consuming, to producing something would be? The difference between. So how much am I benefiting when I produce one more of the X-axis good? My marginal benefit. How much is it costing me? My marginal cost. So like my net benefit, take the benefit, the additional benefit, subtract the additional cost. So for each one of these units, what's true about my net benefits to society? Well, the marginal benefit is greater than the marginal cost. Last week, we said people will choose to do something, choose to buy something, countries will choose to produce it, as long as that net benefit is greater than zero, or said differently, as long as that marginal benefit is greater than the marginal cost. And in fact, we said usually when we identify the point, we say they'll do it as long as it's greater than, or they'll go up to the point where it's equal. We know they're indifferent at that point. They're no better off, no worse off. So where would be the allocative efficient point for this economy to be? So this would be like our quantity that is allocative efficient is where the marginal benefit of the last unit is exactly the same as the marginal cost. So once we've identified this, we have the quantity of good X that's optimal for society. We could then go back and figure out, okay, what combination, what point on that production possibilities curve was allocated efficient. So there's a bunch of different production efficient points using the marginal benefits and the marginal cost. So where do these marginal benefits come from? That's a little more abstract at this point. It's a little bit harder to evaluate that, but we always know that they do exist and they will be downward sloping. That's all we need to know for right now. So once I've identified where the marginal benefits are equal to the marginal cost, one of those production efficient points, and only one point, will be allocative efficient. Yeah. Right here? Yeah, so if I were to stop here, and I was like back here, well, what would be true if I were to produce a little bit more of X? What's the net benefit if I produce a little bit more? Positive, so is my economy better or worse off? If the additional benefits are greater than the additional costs, am I better off than I was before? Yes, so why would I not do that? So we're assuming, same kind of assumption from last class we made for individuals, because individuals make up an economy, people are acting self-interested and rational. What is self-interested and rational? Well, I'm not just going to leave positive net benefits on the table, that's a, so to speak, right? I'm not going to not produce something if it's going to add value to my economy. So as long as that marginal benefit is greater than the marginal cost, we know there's this incentive that the countries and the individuals in those countries will want to produce more of that good, right? Why? Because if they didn't, they'd be worse off. Why would they want to be worse off? Why would you not want to be better off? That's why you would continue to produce up to that. Does that answer your question? Other questions here about identifying kind of allocated efficient points. So this, in terms of like the questions you'll be asked, probably a little bit less like numerical, but more theoretical here, knowing that that allocated efficient point will be the point where the marginal benefit of the last x-axis good produced is the same as that marginal cost. Excuse me. All right. So I think that if I get rid of the stupid Zoom thing, that's basically what this summarizes, right? The fact that we have these diminishing marginal benefits, right? We know that there's going to be some point where those increasing marginal costs, those decreasing marginal benefits intersect. At that point, that's what we're going to say. That's the combination of those two goods. That's the level of production of good X. And then inherently, if I'm choosing the production of good X, if I'm staying on that curve, I'm also kind of choosing how much Y I'm producing. So that's going to be the point that's allocated efficient, or that maximizes kind of what we would call utility. We haven't really used this term yet. Think about it as it maximizes like happiness or net benefit for society here. Okay. So yeah, and I had this other example I was thinking about, I didn't use earlier, but like we've got two things that we're producing, like writing songs or writing academic papers. Academic papers are great because it pushes our society forward. But we don't want every single person doing that, right? Because our lives become very boring and very mundane, and right, we want some things that bring us joy other than work. So we want people doing things like the arts, like writing songs, drawing beautiful murals, right, creating sculptures. And so what combination of those two goods would be, optimal for society? Well, we know that initially, like having some of these things like the arts, having more people writing songs, creating sculptures, that's good. But we also don't want every single person in society doing that, because then we don't really advance. We don't have iPhones that make our life enjoyable. We don't have all these other things. And so there's always this trade-off. What's the point that's allocated efficient? The point that will be allocated efficient is where the marginal benefit is equal to the marginal cost of that last x-axis good produced. And this would apply if we were thinking about like producing 50 goods. It's just the math is complicated. And we're not going to push it that far, right? But as long as we understand the intuition behind a two-good model, same kind of principles would apply to looking at 50 goods. We just have to take like linear algebra and these other math classes in our fun. All right. And this is, we already identified this. I skipped ahead a little bit, right? We drew out how we identify that allocated efficient point. So the next thing that we're going to talk about, where are we at on time? So we go till 9:15. Okay. So let's say I've got my production possibilities curve. I'm currently at this point, right? So whatever combination of X and Y I've decided is my allocated efficient point, that's where I want to be. Okay. Let's say I've got something that causes an outward shift in this production possibilities curve. So what are some things that might cause this, right? Well, if I'm using all of my resources, right, that means that how do we find those extreme points? We said, if I only want to produce the x-axis good, I took everybody in my economy and I added up how much of that x-axis good they could produce. So if I have more people, if my population grows, what's going to happen to that level of production? If I'm only producing one good, I can now produce more. So what might I want to do if I was a smart country? I might really like to start my population, like in the US, the birth rate's below 2, my population is not replacing itself. Maybe I let more people into my country, right? I have more resources that are available to produce these goods, right? And so here, population growth, you can also think about this as anything that I can increase the number of individuals that are living in my economy. Technology changes. So this would be the idea that everybody in this room, and when we look at the pack back assignment, I'm alluding to it, I'll kind of allude to it a little bit here. Thinking about things like ChatGPT, even if I were to use all of your resources, all of your time to produce, I don't know, maybe I just want you guys to write me like movie reviews. I don't know. How could you be a lot more efficient using ChatGPT, right? Using the same amount of time, you could write me more reviews for more movies, right? Probably cheating a little bit, right? But using it to create these, anytime you have a technology change, everybody's time, right? Though that resource of time becomes more valuable, becomes more productive. So anytime we have a technology change, no matter how much of this do we want to produce, we can now produce more of it, right? Even keeping the same amount of X, right? We can now produce more Y because of this new technology change. And then you could have changes in the productivity of your workers. So maybe this is, I think this kind of goes hand in hand with technology changes. But another thing that this wouldn't quite go hand in hand with technology change, why are you guys here? What do you think is going to happen by going to college? I mean, maybe you're just here to have a fun time, right, on your parents' dime. But most of you probably want to make more money once you leave, right? Why can you make more money? Because to a company, you are more valuable, right? More valuable to a company means you, using all your resources, can produce more, right? Human capital, right, or increases in worker productivity would also lead to increases in our economy-wide production possibilities curve. So as an economy, why do we like universities? Why are they often funded, right? Like why does the universities receive public funding? Because we know there's benefits to society, right? We can shift out our production possibility curve, not just of like X and Y, right? We'll have every single good, right? So these are the things that we kind of think about as shifting out our entire production possibilities curve. Technology changes, capital changes, whether or not that's human capital, right? Just being more productive workers, whether that's not having technology that makes you more productive. Right? So we kind of see these outward shifts, right? So notice what's true about a point right here. Before this technology change, what would be true about this combination of good X and good Y? Unattainable. After I see this technology change, this point is actually now inefficient. I can even get to a point that's even further out, right? So we like technology changes, or it shifts outward in our production possibilities curve, because what does it do? It makes points that were previously unattainable now easily attainable. In fact, we can get to points even further out, right? Now, I tried to draw this to scale, but notice if these technology changes impact both goods evenly, what should be true about that kind of shift? We would say these two lines should be, like I said, I tried to draw them to show this, but they look like they are, and they're not. If I have two lines that are like this, they would be parallel. So it's like a parallel shift, right? The difference between these two lines at any point, right, we're kind of thinking about is the same. Okay. Now, what's more likely to be the case, and what might be a little bit more interesting, is if we had something like, I have iPhones and wheat here, right? So I've got a technology good, and I've got an agricultural product. So let's say I have some new technology advancement. I don't know. I feel like I read about this, and I just forget. I read too much and I forget. I don't put things in my memory well enough. But it's like something about what's used in the batteries of iPhones is like a very scarce resource. What is? Does anyone know what it is? The lithium. I feel like I read something about like they found a way to like dramatically improve or like decrease how much they needed, or the life of whatever it was. And so if I had some new technology advancement that comes about where this good is now, I can produce it, right? I can now, using the same amount of resources, produce even more, right? But that discovery, what does it do to the production of wheat? And as far as I know, combines don't rely on lithium. I don't know, maybe they're going, a different, maybe they're coming up with like these new electric combines and things. But you could think about, choose another example where you have a technology change that's only going to impact one of these goods. So if that's the case, if I'm only producing wheat and this technology change didn't impact wheat production, it only impacts iPhones, what's going to happen to the total amount of wheat I can produce if I'm only producing wheat? No change. What about if I'm only producing iPhones? Well, now using all of my resources, if the resources I have, I don't have to use as much lithium for each iPhone, I can now produce more, right? So we can kind of think about anytime we have technology changes, right? I'm going to see it, if it only impacts one good, I'm going to get this not parallel shift in my production possibilities curve, but I'm going to get a shift only on one of the axes. So let's think about exactly what this would do here. Oops, I don't want my laptop. I want this. And now I think I might have screwed this up. So hold on. Okay. You guys can see this, right? Okay. So let's do the one that I had up in the slides. Make sure we're good on time. Okay. Start hurrying up a little bit here. So let's say initially, this was my production possibilities curve, and we had that change in technology that only impacted iPhones. Okay? At the same level of wheat production, sorry, I got lazy there. So if I'm being production efficient under both scenarios, so here is like before the technology change, here's after. What's true about the slope of my production possibilities curve before that change relative to after? So I try to draw this to scale, but if this is increasing and this isn't, and you could actually do a quadratic equation and prove this, but take my word for it, right? For right now, if you want a mathematical proof, we can go through it. But you can, I think, see with this visual, if this curve is going up, what's happening to my slope? It's becoming steeper. So what's happening for that same, let's say it was, I don't know, 50 units of wheat that we wanted. What's happening to my slope? It's becoming steeper, which means my costs, or the marginal cost of that last unit of wheat produced, is going up, right? And think about why. Well, because now with this new technology, if I use my resources to produce wheat, before maybe I was only giving up 20 iPhones. Well, now produce that same amount of wheat, because I have this new technology, instead of 20, I could have been producing 40 iPhones, right? So now the same levels of production of the x-axis good, if my y-axis good has experienced a technology change, I'm going to have to be giving up more. My costs have increased. Okay? So just to kind of tie these concepts together, and before I even draw it out, I'll ask the question. So if I was thinking about the allocative efficient point, right? What's true about the marginal benefit of wheat? Well, it hasn't changed, right? It is what it is before the technology changed. So what was the marginal cost before? Maybe it was somewhere like this, right? So maybe we think about initially, here was my allocative efficient, and I'll call it 1. That was my starting out, my allocative efficient quantity of wheat, where the marginal cost was equal to the marginal benefit. If my costs have went up, I chose 1 point here. Notice what's true at every single point. This curve is now steeper. So at every single quantity of my x-axis good, what's happened to my marginal costs? They've went up. What would that look like here? Well, at the same quantity of my x-axis good, my marginal costs are now higher. My marginal cost here would be higher. So kind of after that technology change, right? Now where is my allocative efficient point? Going to be a little bit lower. And that kind of intuitively makes sense, right? If my economy, if I start to have technology advancements, right, to where producing agricultural products like wheat become more costly, what do I want to do in my economy? Not produce as much of it, right? It's more costly for me. I want to produce the things that are at a lower cost to me, right? And so what might I do, right? We talked about it last class. I start to produce more iPhones and technology products And then how can we all be better off? I start to trade with countries who didn't maybe have these same technology advancements, right? Their costs are still whatever they were before. So anytime these technology changes don't have to be universal to every country, right? So I don't know, trying to tie all these things together. Do you have a question? Okay. Yeah. Any other questions before we keep moving here? Okay. All right. So bounce back here. Let's see, how many more do I have? Covered some of this. What do I want to make sure I have time for? I think we'll have time. So we just did this. We talked about our marginal costs are increasing. We said, what impacts would that have? So we can also model this. And I've been using like wheat and technology products. If you look at like different economic models, a lot of the times what they'll call this is really a trade-off as well between consumption goods, things that our people use. So like wheat and iPhones would be consumption goods, and then capital goods. This is like investments that we're making in infrastructure, investments we think that are going to pay off in the future, right? Making more investments into, advancing technology, right? Because we just saw improvements in technology. I didn't mention this, but they also do what? They make some points that were unattainable now attainable, right? So we want these technology advancements. The only way that we get them are investing into what we call capital goods, right? Investing in these things that might not have immediate payoffs, right? But that have long-term kind of payoffs in terms of advancing our society, our economy. Usually the easiest way to think about this, the payoff is through improvements in technology. Okay? So what does this look like, right? We can model this very easily as consumption goods, capital goods, and we can think about if my economy just starts consuming more products, like my people are spending more and more money just on fast food as opposed to on their education. Education would be a capital good. Well, as I invest more and more into these consumption goods, what's happening to my marginal costs? Same kind of idea. As I invest more and more in a consumption good, how much am I giving up in terms of the capital good? It's going to be increasing, right? Or the marginal cost to consuming more of these consumption goods is increasing because I'm giving up more, right? I'm not putting as many resources towards things that are going to advance my society through technology, through human capital, things like that. So we can use this model and apply it not to just like easy like production kind of two goods, but also this decision that countries have between capital and kind of consumption goods. Okay. Nope, I didn't want to do that. Sorry. I'm going to leave this up here for a second. There we go. So with this in mind, I've got another model that we'll think about, which is, I think I want this to be, the amount of money I'm investing or the quantity. Here, we'll think about it easier. I'll do dollars. The amount of money investing in the capital per worker. And as a result, I'm going to get a certain output per worker, right? So if I invest more into my workers and my economy, they're going to become more productive, right? If I put more money towards public education, right, like Pell Grants, things like that, I'm going to end up with a more productive society. So initially, right, maybe investments into my workers, I start to give them things, right? So investments into capital as a as a company could be as simple as I'm giving them a safe place to work, right? That's going to allow them, I'm giving them the materials they need to fix a car, right? I'm then providing them a garage, right? So I'm giving them these capital goods they need to become more and more effective. Now, eventually, I start to invest more and more into the capital. I'm starting to give them things that are like not as necessary, right? Maybe I start to give them benefits packages that make them feel a little bit better, right? And so they work a little bit harder, but it's not as effective as when I just gave them wrenches and, you know, whatever tools they actually needed to fix cars. So this output per worker, as I invest more and more into capital, it's the same kind of idea that initially I'm going to get very large increases in output. As I invest more and more, I'm investing into like less and less efficient capital. And so the increase I'm getting in the output per worker is going to be lower and lower. Right? So ultimately what I want is I'm thinking about, as I invest more and more into capital, I am getting more and more output per worker. What did that look like when I invest more into capital? It was kind of like I'm getting this kind of like increase right here, right? So I can kind of get to higher levels, right, over time with these technology changes. So this is, I don't know, in the book kind of talks about this relationship between the amount invested capital per worker and the output per worker. And we're sometimes kind of thinking about that. What do I want to have here? So what is the optimal level? Well, really, it goes back to the slope here would represent what? So these consumption goods, the slope would represent my marginal. What's the slope of my production possibilities curve? The cost of my x-axis good. So I'd have my marginal costs. You can kind of think about it here. So that was the marginal kind of cost of consumption goods. I could do 1 over that to find the cost of my capital goods or my capital investment. So if I had my marginal costs, what are the marginal benefits to investing into capital goods? Well, as I invest more and more into capital, what would the additional benefit be? Well, what was the change in my y-axis good here? Or what was the change in output I was getting per worker from each dollar additionally that I invested in the capital? So my kind of per worker production function, the slope here is going to tell me my what. So if I invest this additional amount in capital, this is the amount of additional output I get. So this would be the additional output. We can think about it as the marginal benefit. So using the per worker production function, I can determine marginal benefits. Using this kind of trade-off between consumption and capital goods, I could find the marginal cost of investment into capital goods. Now I've got a point I can figure out what's the allocated efficient point, or what is the optimal investment into capital goods for my society. So very similar to what we were doing before. It's just we've now phrased things in terms of capital and consumption. And now our marginal benefits, we can actually think about like, oh, where do these actually come from? So this is not a production possibilities curve, right? Because this is just analyzing the relationship between, if I invest money into my capital, how much additional output am I getting per worker? Right? The per worker production function is what this, so there is a function behind this. In fact, instead of writing it out for you, I know that it's in the slide, so we'll jump back and forth a little bit. All right. So, and I think I had, there we go. So this is kind of outlines a little bit more of what I was getting at. So as I start to invest in the capital, like the first $100, maybe my workers can produce 500 of whatever this good is. Now the next 100 I invest, it's you know, I'm investing in things that if they would have been the most efficient, I would have invested in them first, right? You kind of think about a company. What do they start to put money into? What they think is going to have the highest payout. So they might put money into, you know, marketing towards a demographic they think they can get the most consumers or customers from. So the first $1 million they spend is going to be very effective. Well, then the next million they spend, they've already targeted this group. They target the next group of consumers. Well, that same $1 million, that is the second consumer base it's not as productive, right? Those consumers, they would have targeted them first if they thought they were their main consumer base. Same idea. We invest into projects or into capital that we think is most effective first. So the first $100 might produce 500 units from our workers. The next $100, well, now we're only going from like what, 500 to 900. So we're only getting an additional 400 units. And then the next $100, we're going from 900 to 12. So we're only getting 300. So as I invest the same amount in the capital here, I'm getting a lower and lower amount of additional output, or my marginal benefit is decreasing, like what we said earlier, right, with our other model. So, yeah, this would be our kind of per worker production function. It's not a trade-off. It's telling us the relationship between as I invest, and I think I might have had it, there we go, more and more into capital. So here we'll call K capital. The other things that we have in our economy, so we don't want to think about this more of like a company standpoint, but an entire economy. We've got land, natural resources. So this is things like gold, iron, whatever, raw materials we need. Labor is going to be our population, our working population. Capital is going to be like machinery, right? Things we start now. We said we also can have human capital, right? We can invest into our workers' education, or we can invest into technology products that give our workers more capital. But the amount of output we get, right, per worker is going to be some function of all those things. It doesn't matter if I have 50 million people, if I don't give them any raw materials or a place to work, how many cars can they produce? Probably not, right? So it's going to be some function of all of these things. I need some labor. I need some investment in my capital products. I need some land to have them to be able to work on. I need natural resources, the raw materials they need to produce products. It's going to be some function of all of those things. Now, it's going to get multiplied by whatever level of technology I have. So we'll call that A, right? So even if I were to use the same combination of capital, labor, land, natural resources, if I have technology improvements, that would lead to a higher level of output. Right? That's all that function's telling me. And I won't kind of go too much into the weeds here because I'm not going to ask you a ton of questions on this in terms of quizzes, things like that, but just kind of more showing you like where we would kind of progress these models towards, right? We already talked about this. The marginal benefits are declining. I think I'm going to save time. I might change here. So we'll come back to this. I want to make sure that for those of you who are here, kind of get this out of the way. We've got a little more time, but I just want to make sure we have time for this. Oh. Any longer than this. So you should be able to find that Canvas quiz now on the main homepage. I'll kind of start walking through it. Like I said, getting it pulled open. All right, we'll walk through these a little bit together. That way you can kind of wait if you're getting kind of the spinning wheel. So the way that, this one is going to look a little bit more like what they traditionally will. So Tuesdays was kind of a test run. And once again, I wasn't even sure if we could use Top Hat or not. So generally, I'll kind of set this first question. Just basically, if you were here kind of answering, yes, I'm here, you get half the credit for the day, right? So each class we use these are worth like a total of 2 points, right, for each day. So 1 point for just simply answering this question. You don't even give an option, so hopefully you can't screw this up unless you don't answer this, right? Now, the other 2 questions we have here, generally, I'll give you a little bit of time and then we'll kind of talk about these, okay? So the first one, if we've got an economy, we're producing nuclear coal power, and we have a technology advancement that does not impact coal, but it does impact nuclear power, what's going to happen to our production possibilities curve? Right? The second one, after we see a technology improvement, investing the same amount of capital per worker, what are we going to see to the output? So we didn't quite cover this, but I want to see if you guys can kind of guess this before we get over. So I'll give you guys about, like I said, 10 minutes or so, or a couple minutes here to work with people around you. Just think about this question mainly, making sure you're kind of answering this to get it correct. We'll then kind of go through question 3 together, which is if I have this per worker production model, if I did see an advancement in technology, what's going to happen, right? That per worker production curve, right? And then we can kind of think about, are you going to be more or less likely to have a comparative advantage? So focus on 2, think a little bit about 3, and then we'll kind of come together and talk about it. Okay. All right, so it won't be as friendly on 2, so sometimes I would hold off. Did everybody already submit the quiz? Yeah? So in the future, I would hold off on submitting because I might be friendly. So I'll tell you kind of on question 3. So we should see that we can increase in the output per worker, and it's going to be more likely, right, that they have a comparative advantage. So I'll go through this why in a second, but if you haven't submitted already, increase and more should be the correct answer here. And then we'll talk about 2. I'm not going to give you the answer to, but just 3 here. Okay. So make sure you get this submitted. I think I have it set to be due at 9:10. So make sure you're getting this submitted here before the due date. That'll be the credit for being in class. So we'll first start talking about 3 since I gave everybody the answer to it, and then we'll kind of go back to 2. So on question 3, if I were to see a technology advancement, remember I said this is like the relationship between capital invested, or K, and the output Q that we're getting. I said, what's the total output though? It was that function multiplied by how much technology we have. So if I see a technology advancement, if I'm investing the same amount into my workers, what do you think happens to the output I can get? It should. So if I'm investing the same amount into my workers, and I now have these new technologies available for them, they should be able to produce more. So at every point, I should be thinking about investing the same amount into capital, I can get more output per worker. Okay. Now, I also tried to draw this to kind of scale here, but you can think about, and I don't like the phrasing that question. I'll probably go in and edit a little bit, because when I think about comparative advantage, I was thinking about a comparative advantage in these products that experience a technology change. So there we would need to kind of look at that trade-off between the capital and consumption goods. I just wanted to highlight here, it doesn't matter which good you put on the x-axis. And in fact, here, if I'm thinking about these capital goods, right, this is where I saw this technology change occur. I might actually want to analyze the cost of my capital goods. Well, the slope, it's probably easier. Whatever good I want the cost of, the slope tells me the cost of my x-axis good. So if I'm thinking about, I saw a technology advancement in these capital goods, I'm going to put it on my x-axis. So I now know I can produce more of it at the same level. Notice what has happened. Try to draw this to scale, but like what's happening to my slope at the same quantity of investment into capital goods now? It's becoming slightly flatter. So what's happening to my marginal cost of producing that same number of capital goods? It's going down, which is that more or less likely I have a comparative advantage. If my costs are lower, it's going to be more likely, right? Who has a comparative advantage? Whoever has lower costs. So these technology improvements, right, will decrease my costs in these products. Here we were thinking about capital product good, goods that were capital intensive, and makes it more likely I have a comparative advantage in that. So I'm trying to kind of tie a lot of these concepts, right? We're going back and forth between talking about the slope, it representing costs, looking at the capital consumption good model. It's very similar when we had like these two good models. But that's why that second one would have been that we saw an increase in our per worker production function. That new technology then led to a lower cost for our capital goods, making it more likely we had a comparative advantage. Okay. Any questions on that question? So when it's shifting out on one axis, inherently, you can think about that as it's making at every single point, this curve has to be flatter. The only time we see a complete shift, which I think was, what did I have question 2 be? Oops. Question 2, I still had only changing 1, right? Yeah. So question 2 is very similar to this. It's just on my x-axis, I would have had what? Nuclear power. And up here, I would have had coal power. So it should be that if I'm putting nuclear power on the x-axis, it's going to shift out because of that technology advancement, right? It would be the exact same model for question 2, but we'd be thinking about we had nuclear power down here and the quantity of coal power up here. Anytime your intercept shifts on the x-axis here, that curve has to be getting flatter. If it was the y-axis good that saw a technology shift, what's happening to my slope? Steeper. The only time I get a parallel shift is if that technology change impacted both goods, right? So the only time I see these parallel shifts are if I have increases in my population, increases in technology that impact both goods, or we said increases in human capital or productivity, right? But anytime I have a technology change that only impacts one good, if it's the X good that's impacted, it's going to become flatter. If it's the y-axis good that's impacted, it would become steeper. Right? Was that your question? Okay. And to be completely honest, this might be pushing you a little bit further if you look at those practice problems than I even would. So got a couple minutes here. I want to mention some things before we get out of here. So didn't have time for some stuff. I wanted to talk a little bit about compound interest. I might, if we have time, I'll start class with it or with it and throw it into Tuesday's class. The two things I do want to mention. First, the CL sessions will start tonight, right? So I'm going to put up an announcement. There's one of the leaders that can't make it. So I forget, I think it's 3075 is the one location tonight that won't have anybody there. But there will still be 2 locations at every single time slot this evening for those CL sessions. Also, all the time slots should be available that I've got posted up there on Canvas for Sunday. So you can find a reminder of those right here. So this is like every single person, kind of where your assigned time slot was. But I also just put up a little summary of those times and the locations that are available. Like I said, I believe this is the location that's not available. I'll post a Canvas announcement later today, though, of which one exactly won't have someone there. That pack bag assignment will also pop up. So I've got Packback signed in here. Right. So what you'll see is this initial guidepost. So it's got a couple articles. It's got my thoughts. I post some questions. You're going to go. Oops. hit this big red button to post your initial response or ask your initial question. Once you do that, it'll post it up there. You then need to respond to 2 other students' questions or their initial posts, right? So should have saved a little more time to talk a little bit more about this. I'll start with it on Tuesday, but if you want to get an early start on this, right, kind of read through these articles. You don't have to go through them with a fine-tooth comb, but read through these articles, read what I wrote about them, and kind of respond to that guidepost with your initial response. And then as other students start to respond, you'll respond to 2 of their posts, okay? It'll be related to kind of stuff we talked about today, ChatGPT, productivity, kind of use some of the models and concepts we talked about. Other than that, if you have questions, feel free to come up after class. I know we ran into the end of class a little bit. Have a fun, safe weekend. I'll see you guys on Tuesday.
How do we find our names?